Hi student, yesterday we see exercise 1.3 question number 2 and the last question of question number 2 is what y is equal to tan x raised to tan x whole bracket raised to tan x at x is equal to pi by 4. Then we have to find the value of dy upon dx at x is equal to pi by 4. So first we find dy upon dx, then use instead of x, that is pi by 4. So first taking logarithm on both sides. Taking logarithm on both sides. Therefore here log y is equal to log of tan x raised to tan x raised to tan x. So by using exponent law of logarithm, here we write tan x into log of tan x raised to tan x. Log of tan x and raised to tan x by using exponent law. Again look at here, tan x write as it is now, which is again in the form of log m raised to n. So again write tan x into log of tan x. Tan x into log of tan x. Now look at here, tan x into tan x. If x into x, then we write x square. So here tan x into tan x, that means we write tan x whole bracket square into log of tan x, which is equal to log y. Now we can differentiate the function with respect to x. Differentiate with respect to x. That means what is derivative of log y? 1 upon y into derivative of 1 dy upon dx is equal to, now here I am using product rule of derivative. So first write first function as it is, tan x square into, take the derivative of second function. What is derivative of log of tan? That is 1 upon tan into, what is derivative of tan x? This is composite function, sec square x plus, now look at here, now the second function as it is, log of tan x as it is, into take the derivative of first function. So this is power function, f of x raised to n. So what is derivative of this? 2 into tan x. 2 into derivative of tan x square, that is derivative of x square is 2x, into multiply the derivative of tan x, that is sec square x. Therefore here dy upon dx is equal to dy upon dx is equal to y into, now tan x square upon tan x, so one tan will be cancelled here, tan x into sec square x plus log of tan x into 2 tan x into sec square x. Now use value of y here. Therefore dy upon dx is equal to, what is value of y? Tan x raised to tan x and whole bracket raised to tan x into, write the function in bracket as it is, that is tan x into sec square x plus log of tan x 2 into log of tan x into sec square x, 2 into tan x into sec square x. But this is dy upon dx and we have to find the value of dy by dx at x is equal to pi by 4. Therefore dy upon dx at x is equal to pi by 4 is equal to, so instead of x here we use pi by 4, tan pi by 4 raised to tan pi by 4, again whole bracket raised to tan pi by 4 into, right, tan pi by 4 into sec square pi by 4 plus 2 into log of tan pi by 4 into tan pi by 4 into sec square pi by 4. And all of you know the value of tan pi by 4. Tan pi by 4 is equal to 1. Now what is sec square pi by 4? Sec pi by 4 is root 2. Sec pi by 4 is equal to root 2. So use these two values here. Therefore dy upon dx at x is equal to pi by 4 is equal to tan pi by 4 is 1, 1 raised to 1, 1, again raised to 1, that is 1. Now again tan pi by 4 is 1, sec square pi by 2, that is root 2 square, plus 2 into log of tan pi by 4 is 1 into tan pi by 4 again 1, and sec square pi by 2, that is root 2 square. So here look at here, the one root 2 square is 2 plus 2 into, we know value of log 1, that is 0. Again the root 2 square is 2 here. Since value of log 1 is equal to 0. Therefore the 2 into 0, that becomes 0. So answer of this dy upon dx at x is equal to pi by 4, which is equal to 2. So the question 1 and question 2 in exercise 1.3, the all questions are depending on the logarithmic functions. Now we are going to start our new point, that is implicit functions. Next point, implicit function. So first of all, what is meant by implicit function? And the examples which we already studied, these are the type of explicit functions. First of all, what is meant by implicit function? So before we see implicit function, we see what is meant by explicit functions. The examples we already solved in earlier lectures, these are of the form explicit functions. Explicit functions. So what is meant by explicit functions? The functions of the form y is equal to f of x, or functions of the form y is equal to f of x. That means the all functions, the here we write y is equal to x square plus 3x plus the right side which is in the form of x. So here y is a depending function of x. Y is depending function of x. If y is a variable of x, then the functions of the form y is equal to f of x is called as an explicit function. Now we see one new point, that is implicit function. Now implicit functions means what? A function which is neither in the form of x or nor in the form of y. That is, x is not in the form of x is not the function of y, or y is not a function of x. That means this is of the form f of xy. This is of the form f of xy is equal to 0. Here look at, these are different forms. Y is equal to f of x. That means y is a function of x only. And in the type of implicit function, which is not in the only form of, not in the form of only x or not in the form of only y. This is in the both form, that is f of x comma y. Suppose for example, ax square plus 2hxy plus dy square is equal to 0. X raised to m into y raised to n is equal to x plus y raised to m plus n. Next, x cube plus 2xy plus y cube is equal to 0. These all functions are called as an implicit function. That means which is neither a function of x nor a function of y. These functions are called as an implicit function. There is difference between explicit functions and implicit function. So now we start to solve our exercise 1.3, that is question number 1.3. First of all, we should try to understand the difference between implicit functions and explicit function. There is many difference between implicit and explicit. If it is a function of fy is equal to f of x, then we take direct derivative, differentiate with respect to x, then find the derivative. But in this side, we take differentiate with respect to x. And if instead of this y, we have to differentiate y with respect to x, then what is derivative of this? That is dy upon dx. If we have to find the derivative of y square with respect to x, then what is derivative of y square? That is 2y. But we differentiate with respect to x, since we write into dy upon dx. This type of functions are called as an implicit function, which is neither of the form x nor of the variable y, is called as an implicit functions. Now we see exercise 1.3, question number 3. Question 3. What is first question? Differentiate following with respect to x. So first question is what here? Root x plus root y is equal to root a. Root x plus root y is equal to root a. We have to find dy upon dx. So first I differentiate with respect to x. Now all of you know the derivative of root x, that is 1 upon 2 root x. Plus, now what is derivative of root y? If derivative of root x is 1 upon 2 root x, since derivative of root y is 1 upon 2 root y. 1 upon 2 root y. But look at here. Here we differentiate with respect to x. That is a derivative of root y. But the remaining part means the derivative of dy upon dx. This is a derivative of y and this is a derivative of root y. Is equal to derivative of root a is 0 because it is constant. Now I am taking 2 common from this and from right side it becomes 0. Therefore 1 upon root x plus 1 upon root y into dy upon dx, which is equal to 0. Therefore 1 upon root y into dy upon dx is equal to minus 1 upon root x. Therefore dy upon dx is equal to minus root y upon root x. We write this in a single root, that is root y upon x. That is answer of this first question is minus under root y upon x. Now see second question, that is x root x plus y root y is equal to a root a. X root x plus y root y is equal to a root a. Now this is the same variable, so first we arrange the terms. Here x as it is and root x can be written as x raised to half plus y as it is, root y can be written as y raised to half a into a raised to half. Now we adding this power, so x into x raised to half, that means x raised to 3 by 2. Here power is 1, so 1 plus half, that is x raised to 3 by 2. Here y raised to 3 by 2 is equal to, look at here, x raised to 1 into x raised to half is equal to x raised to 1 plus half, since a raised to m is equal to a raised to m plus n. Now differentiate with respect to x. That is derivative of x raised to 3 by 2 by using power function. 3 by 2 into x raised to 3 by 2 minus 1 plus 3 by 2 into y raised to 3 by 2 minus 1 into, this is a derivative of y raised to 3 by 2 into multiply the derivative of y, that is dy upon dx. Here derivative is 0 since it is constant. Therefore 3 by 2 as it is, 3 by 2 minus 1, that is 1 by 2 plus 3 by 2 into y raised to 1 by 2 into dy upon dx is equal to 0. If we divided 3 by 2 on both sides, then this 3 by 2 will get cancelled. X raised to half can be written as root x plus root y. Dy upon dx is equal to 0. Therefore, this root y into dy upon dx is equal to minus root x, and therefore dy upon dx is equal to under root x upon dy. Question number 6. Now see question third, x plus under root xy x plus root xy plus y is equal to 1. Plus y equals to 1. Right, differentiate with respect to x. Don't differentiate directly, first we write differentiate with respect to x. Tell me derivative of x, that is 1, plus what is derivative of root xy, which is in the form of root f of x. So what is derivative of this? 1 upon 2 root f into derivative of f dash. So here I am taking derivative of root xy is 1 upon 2 root xy into multiply the derivative of root xy. This is the derivative of root xy, that is 1 upon 2 root xy into derivative of root xy plus derivative of 1 dy upon dx is equal to 0. Sorry, 1 upon 2 root xy into derivative of xy. This is the derivative of root xy plus dy upon dx is equal to 0. 1 plus 1 upon 2 root xy into find the derivative of xy by using product rule. So first x as it is into derivative of 1 dy upon dx plus y as it is derivative of x is 1 plus dy upon dx is equal to 0. Now we multiply the 1 upon 2 root xy. 1 upon 2 root xy. So first we multiply this first term. So x upon 2 root xy into dy upon dx plus y upon 2 root xy plus dy upon dx is equal to 0. Now look at here. Here is x. So instead of x I am writing root x into root x. Root x into root x means what? Root x square. And root x square means only x. So here instead of x we write root x into root x. And here instead of y we write root y into root y. 1 plus root x into root x divided by 2 under root xy into dy upon dx plus root y into root y divided by 2 root of xy plus is equal to 0. Now look at here. In denominator there is root xy. Root xy, that means root x into root y. The root xy can be written as root x into root y. So root x will get cancelled here. Root x will get cancelled. Therefore 1 plus the remaining part is, if root x will get cancelled here, then here the remaining part is root x upon root y. So we write this in single root plus 1 upon 2 into root x upon root y. Since 1 root x will get cancelled from here into dy by dx right as it is. Plus again here root y will get cancelled. So remaining part is 1 upon 2 into under root y upon x plus dy upon dx is equal to 0. Now take the terms which included dy by dx outside. Dy upon dx into 1/2 root of xy minus 1. From these two terms which are multiplied by dy by dx, I am taking dy by dx common. So remaining part in this 1/2 into root of xy minus 1. And the term which are not multiplied by dy by dx takes this term on the right hand side. So the plus 1 become minus 1 and the minus 1/2 into under root y upon x. Now here I am simplifying these terms. Look at here. The root x into root y, that is root x minus 2 root y. Here if we multiply by 1 2 root y, then it is root x minus 2 root y divided by 2 root y is equal to, again here we multiply the minus 2 root x minus root y upon 2 root x. By cross multiplication I am writing this dy upon dx. Now here the 2 will get cancelled from this is equal to, taking minus common, 2 root x plus root y divided by root x minus 2 root y. This is the dy upon dx. Now next question, in question number 3, that is question number 4. x and root y is remaining part. dy upon dx. Here root x is, if I take minus sign common from this, then 2 root x plus root y divided by root x minus 2 root y, and the root y which is in denominators here, so in this side it is in numerator and it is in denominator. So answer of this is minus root of y upon x into 2 root x plus root y divided by root x minus 2 root y. That is dy upon dx. Now next see question number 4 here. X cube plus x square y plus xy square plus y cube is equal to 81. Right? Differentiate with respect to x. Differentiate with respect to x. Therefore, derivative of x cube 3x square. And to find the derivative of x square y, here we use product rule. So what is derivative of, first write x square as it is into derivative of y, dy upon dx plus. Now write y as it is into derivative of x square is 2x plus, again we use product rule in xy square. X into derivative of y square is 2y into derivative of y dy upon dx plus y square as it is derivative of x is y plus derivative of y cube is 3y square into derivative of y is dy upon dx is equal to 0. Therefore 3x square plus x square into dy upon dx plus 2xy plus 2xy into dy upon dx plus y square plus 3y square into dy upon dx is equal to 0. So for finding dy upon dx, we take the terms which are multiplied by dy by dx common. Dy upon dx into first write coefficient of terms which multiplied by dy by dx, that is x square plus 2xy plus here 3y square is equal to, now take the terms on RHS which are not multiplied by dy by dx, that is minus 3x square minus 2xy and here plus square, it become minus y square. Therefore dy upon dx is equal to, now write minus or sign outside, 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. This is the dy upon dx. Now see next question, question number 5. X square y square minus tan inverse of under root x square plus y square is equal to cot inverse of under root x square plus y square. So first the minus tan inverse write this side, so it become x square y square is equal to cot inverse under root x square plus y square, in minus sign here it become plus tan inverse of under root x square plus y square. And in formulae of inverse trigonometric function we see sin inverse x plus cos inverse x pi by 2, tan inverse plus cot inverse pi by 2, and sec inverse x plus cosec inverse x is pi by 2. So here cot inverse x plus tan inverse x is equal to pi by 2. So instead of the RHS, we write pi by 2 because this. Therefore, x square y square is equal to pi by 2. Now differentiate with respect to x. So use product rule, x square into derivative of y square, 2y derivative of y, dy upon dx plus y square as it is derivative of x square, 2x is equal to derivative of pi by 2 is 0 because it is constant. Now take 2 common from this and or divide by 2 on both sides. Since the remaining part is x square y dy upon dx plus xy square is equal to 0. Therefore, x square y into dy upon dx is equal to minus xy square. Therefore, dy upon dx is equal to minus xy square upon x square y. So look at here, x will get cancelled and here y will get cancelled. So remaining part is minus, in numerator there is y and in denominator there is x. Therefore dy upon dx is equal to minus y upon x. Next, see next question. X e raised to y plus y e raised to x. X e raised to y plus y e raised to x is equal to y. Differentiate with respect to x. Again use product rule. X into derivative of e raised to y, and derivative of 1 dy upon dx. X as it is, derivative of e raised to y is e raised to y and this is the derivative of y. Plus, right, e raised to y as it is, derivative of x is 1. Plus, y as it is, derivative of e raised to x is e raised to x. Plus, e raised to x, derivative of y, derivative of 1 is 0. Now again take the terms which are multiplied by dy by dx that are common. So dy upon dx into x e raised to y plus e raised to x, and the terms which are not multiplied by dy by dx take on RHS, that is minus e raised to y minus y e raised to x. Therefore dy upon dx is equal to take minus n outside. The multiplied term is divided by here plus e raised to x. This is dy upon dx. Next, see question number 7. E raised to x plus y is equal to cos of x minus y. Cos of x minus y. Differentiate with respect to x. Again derivative of e raised to f of x is e raised to f of x into dy upon dx. E raised to x plus y into derivative of x plus y is equal to derivative of cos is minus sin of x minus 1 into the e raised to x plus y as it is into derivative of y x is 1 dy upon is equal to minus sin of x minus 1 into 1 minus dy upon dx. Now multiply e raised to x plus y into 1 e raised to x plus y plus e raised to x plus y into dy upon dx is equal to minus sin of x minus 1 and here minus minus plus sin of x minus 1 into dy upon dx. Now again take the terms which are multiplied by dy by dx common. Dy upon dx into e raised to x plus 1 and the plus here it becomes minus sin of x minus 1. here we use square bracket, is equal to, write the terms, minus sin of x minus y and the minus e raised to x minus. Therefore, take minus outside, sin of x minus y plus e raised to x plus y divided by e raised to x plus y minus sin of x minus y, that is dy upon dx. And if we take minus sign common from this, then the minus minus will become plus, then the answer will be sin of x minus y plus e raised to x plus y divided by, if we take minus sign common from this, then the sign will become plus, and minus minus will become again plus, that is sin of x minus y minus e raised to x plus y. When if we take minus sign outside, then the minus minus will become plus. This is dy upon dx. Now there are question number 8, 9 and 10. So you should try to solve the question number 8, 9 and 10. Next time, in next lecture, we see question number 4. You should try to solve the remaining questions, that is question number 8, 9 and 10. Look at in question number 9, there is e raised to x minus y. e raised to x minus y is equal to x upon y. So here take log on both sides. We can't find the derivative, so taking log on both sides, then it become log of e raised to x minus y is equal to log of x upon y. Since, and we all of you know that logarithmic function and exponential functions are inverse functions of each other. Since the log and 1 e raised to will get cancelled, then the remaining portion e raised to x minus y is equal to log of x upon y. Again the log of m upon n can be written as log x minus log y. And then we will solve the example by using differentiate with respect to x, then find the derivative of this. And the question number 8 and question number 9 are straightforward. So you should try to solve